Welcome students to Algebra 2. We're going to do a quick geometry review. This will be lesson A and lesson B. You're just going to have a video. There's not going to be any practice problems because this should just be a memory refresher from what we learned in Algebra 1 last year. So let's begin by talking about a point. We know a point is position in space. A curve is a shape that does not have a straight path. And a line, a mathematical line, goes on and on forever in both directions. And a plane, which is a slice of existence. You could think of a plane as a piece of paper or a wall. These are all primitive terms. We know a point is a location, and usually we have a graph that defines a point or a line where we can put a point on the line. Sometimes even a plane, we can have 1, 2, 3 points to define a plane. We know that when we write a line, we write it with the arrows, and we usually name it by whatever points lie on that line. Same thing for a line segment. We just leave off the arrows and name it for the points that are on that line segment. We know that parallel lines are two lines that never intersect and are always the same distance apart. We know that intersecting lines are lines that cross at some point, and that point is called the point of intersection. All right, talking about angles, let's clear this. Since this is just a review to kind of get your head in the right direction. Only take notes if you really don't remember this stuff, okay? We know that a line is also called a straight angle, and that it is 180 degrees because it consists of two perpendicular lines, and those are lines that are rotated exactly 90 degrees from each other, and that creates four 90-degree angles, and 90, 90, 90, and 90 is 360 degrees, which is why we say that a circle is 360 degrees. All right, that being said, a right angle is a 90-degree angle. An acute angle is any angle less than 90 degrees and greater than 0. And an obtuse angle is any angle that is greater than 90 degrees but less than 180. If it is 180, it is a straight angle, and no angle can be greater than 180 because when we shift it down, it just becomes the other side. We just flip the degree over. We want to measure the interior angle, not the exterior angle. So this would be greater than 180, but it is the exterior. And we always want to measure the interior. That is why we can never have an angle greater than 180, because once it begins to flip the other direction, we measure the other side. All right, that pretty much covers complementary and supplementary angles. We didn't really go over this in Algebra 1, but a complementary angle is any angle that's right next to another angle that together they make a 90-degree angle. That's complementary. All right, supplementary angles are any two angles that go together to make 180. That's supplementary. And it helps you to remember the two. I like to, I don't know if I can spell today. Down here at the bottom, it doesn't want to write really great, so I'm going to try to Go slow. The thing that helps me to remember the difference is that mathematically or numerically, 90 comes before 180 on the number line, right? You have 90 and then eventually get to 180. C comes before S in the alphabet. So 90 goes with C and 180 goes with S. If you line them up numerically and if you line them up alphabetically, if that helps you to remember the difference. So complementary is two angles that make 90 degrees. Supplementary is two angles that make 180 degrees. I don't think we had that yet in Algebra 1. That's why we're doing it now. You will need to put that in your notes because that's not something we went over. All right, if you need to pause, do so. We're going to finish our review right quick. Something else we didn't discuss is vertical angles. And a vertical angle, let's say we have two angles that intersect. The vertical angles are angles that are across from each other. And they are vertical, right? The angles that are opposite each other are called vertical angles. So these are vertical angles and these are vertical angles. And these would be vertical angles are congruent to one another. So this one is congruent. Whatever this one is, this one is. Whatever this one is, this one is. These two together are going to make, they're going to be supplementary. These two together are going to be supplementary. So it doesn't matter what the degree of measure is. If you have two intersecting lines, these two on this side are going to be 180 and these two on this side are going to be 180. Same thing, these two on this side are going to be 180 and these two on this side are going to be 180. And these are always going to be the same and these are always going to be the same measure. Okay? So two intersecting lines are called straight lines. They form four angles. The angles that are opposite each other are called vertical angles. Vertical angles are always equal angles. All right, so let's do a couple of little practice problems. I'm just going to do them for you. I'm not going to make you struggle through. So just take notes as we go. All right, so in example 1.1, we have a line here. And we have a right angle here. I'll note that. And then we have an angle here that has a measure of 30 degrees. This is angle X. We have another angle here that is 40 degrees. And then we have angle Y. Okay, so we need to find the measure of X and Y. All right, pretty quickly, we know these two are perpendicular because this is 90. So what that means is these two angles are going to be complementary, so they're going to add up to 90 degrees. So if this is 30, X is going to be 60, right? We see that. Also, we know that this is a straight angle, and if this is 40, a straight angle is 180. These are two supplementary angles. So if this is 40, then this has to be 140. So 40 and 140 equals 180. All right, that was pretty straightforward. Now we have two intersecting angles. And let me see if I can get that right. There we go. And we have, this is 50. This is Y, this is X, and this is P. So we need to find the degree of measure for X, Y, and P. Okay, if we have one, we can find the other three because we know that vertical angles, or angles that are across from each other in intersecting lines, are congruent. So it means this is 50 degrees here. We also know that angles across a straight line, this is a straight line, that equals 180. So the difference in 180 and 50 is going to be 130. And again, because these are vertical angles, P has got to be 130 because it is congruent to Y. Pretty straightforward and easy to solve once you understand. So let's do this again. Only this time we have a little bit closer. There we go. The measure of this is 2y. The measure of this is 5x. The measure of this is p. And the measure of this is 110. We really don't need 2y and 5x. We can solve it just like we did up here. But that's okay. What they're wanting us to do is find the value of y and the value of x given the degree of measure in this supplementary angle. So if this is 110 and this is 2y, we know that 110 plus 2y is going to equal 180 because this is a straight angle. So we subtract 110 from both sides because that's how we do in algebra. So that means 2y is going to equal 70, which means that y is going to equal 35. Now let's look at this side. If 2y is 70, well, we know what 5x is because it is congruent to 110. So we can say that 110 equals 5x. And we can divide both sides by 5. And that is going to be 22. So 22 is the value of x right here. And if 2y is 70, then we know that p is 70 because p is congruent to 2y. Okay? All right, now let's look at the review of the absolute value. If you need to take notes, pause. And I'm going to continue after I clear the page. Absolute value is simply the distance from 0 on the number line. Absolute value is always, always, always positive because a length cannot be negative. So the absolute value of any number is going to be its positive. If we have a problem within our absolute value, we solve it and take the positive answer. So 2 minus 6 is negative 4. The absolute value of that is 4. Okay? That's our review of absolute value. Understanding algebra is easier if we make an effort to remember the differences between properties and definitions. A definition is a definition. It's an explanation of what something means. A property is just like a rule, like the commutative property. When we move things around, we know we can move things around. It's just a rule. A definition is an actual description of something because they're things that we have agreed on. For instance, we know that 3 squared means 3 times 3. The definition of an exponent tells us that it means whatever the base times itself this many times. Whereas a property just means we know we can take 3 and 3 and put them in any order and they're still going to be the same answer. It's just a condition. All right, so for example, let's do example A5 is negative 2, that's supposed to be a 2, cubed minus 2 squared minus negative 2 squared. All right, so we know that the negative is within the bracket, so we can say negative 2 times negative 2 times negative 2. That's going to be a negative 8. It retains its negative value because it's within the parentheses. This, however, does not because it's not in parentheses. So 2 times 2 is 4, and we have a negative, so it's a negative 4. Now here we have negative 2 times negative 2. That's a positive 2, but then we have a negative asking for the opposite on the outside. So that's going to be a negative 4 as well. So our answer is going to be a negative 16 because these are all negatives. They all have the same sign, so they're all combined and they keep the same sign. All right, that's all I have for lesson A. Go ahead, take whatever notes you need to take from this video and move on and watch lesson B.